So welcome. Hope you guys had a good week. And I just want to say one thing before we start. I don't know, on your Zoom view, I think you can see like the participants' names. It says that my name is Diana. That's not my name. My name is Amber. I'm using my mom's Zoom account. So just to clarify that Diana is not my name, because I didn't want to mess with her settings. I changed them last time and she was like, change it back. So I'm going to be sticking with this screen name, but my name is Amber, not Diana. So anyway, so today we're going to be talking about equations this time, and which are like insanely important for higher level math. So what is the goal of an equation? You probably like have heard of this in other math classes or something, but like the ultimate end goal of the equation is to basically solve for x or whatever variable that you might have, right? So I'll give you some context as to why we are doing this, and I'll also explain a couple of these definitions, and we'll go through some practice problems together. Okay. So I'll first explain these definitions. So an expression is a representation of a minimum of two terms and one math operation. And an equation is basically where you have an equal sign that is connecting expressions in some way. So I will write some examples. I will switch to red this time because hopefully you don't mind. Some people don't like reading the color red. Okay. So an example of an expression would be like 3x plus 1, right? 3x plus 1 is two terms and one math operation combined together. So then the equation, it would be maybe like 3x plus 1, and then we would need an equal sign to connect some expressions. So I could like make one up, x plus 2. So this would be an equation, and the first thing right here is an expression. So there's a difference between these two things. Some people and like students and math teachers alike might make the mistake of saying these two terms interchangeably, but I want to remind you that these two are not, they're not the same, right? Expressions and equations are two very different things, so you want to keep that in mind, right? Even though they both start with an E or whatever. So just keep that in mind as you're like navigating through your math courses. Like just be aware of the notation and the words and the definitions that you're using, because it'll get really confusing, and then you might like make a mistake because you didn't read it correctly or whatever. Okay, so I'll give some context as to why we are doing this, because equations are probably like maybe one of the most important things in algebra. So, hello. Okay, so some context. We're going to be, in this lesson, we're going to be solving pretty simple equations that are in the first power, right? So our end goal is to get the variable by itself to equal a number that is in the first power. So like in future classes, what if we had like, we will be solving equations like this. Actually, we'll be doing it in this class towards the end, I think. So like x squared equals 4, right? Well, how do we get this to the first power? To get it to the first power, we have to square root it, right? We have to square root both sides, because we have, whatever we do to one side, we have to do to the other side of the equal sign. So if I take the square root of this part, I also have to take the square root of this part. So then x ends up being the square root of 4, right? But in this case, it would have to be x is positive 2 or negative 2, because you can square a negative under the square root. So in this case, x equals plus or minus 2. This means that x equals positive 2 or negative 2. So that's kind of like what we will be doing a few weeks down the line. So that's how you get it to the first power. That's why it's so important. We want to get it to the first power, because if we have like x squared or x cubed, that doesn't really mean anything, right? We're going to have, in those cases, we're going to have more than one solution. I'll explain that later in future weeks. And then like in the future, you'll be solving very complicated equations, maybe in the form like this. So let's say I had 2x plus 1. I don't know, 3x plus 3, x plus 7 equals 0. And then you'll be asked to solve this whole thing. So like, how do you do that? Well, understanding this lesson will help you with those future classes, but this is not important. We're not going to be doing these complicated ones today. So don't worry about this. Don't worry about these. For now. So today we're just going to be solving some basic like single variable to the first power equation. So it'll just be like mx to the first power. So that was some context. Just wanted to provide that because sometimes you're in a math class and you're like, why am I doing this? Well, you're going to have to be doing this in the future a lot. Okay, so how do we solve equations? Well, we can, whatever we add to one side, we can always add to the other side of the equation. And then whatever we subtract from one side, we can also subtract from the other side of the equation. So it's kind of like think two balances, right? We want both of the balances to be the same, to weigh the same amount each time, right? We can't suddenly take like a huge amount from this one because it's going to cause our balance to tip over. That's kind of the principle of this. So we want both sides to stay, we want to do the same thing to both sides each time so that our balance is stable. So I like to teach by example, so I just go straight off the bat with some examples. So in this case, we're solving for m, our first example. 2 fifths equals m minus 1/5. So I decided to put some fractions and decimals in here. Hopefully you guys know how to work with those, but I really like to use those kinds of examples because in the future you'll be doing a ton with like complicated numbers. And it's really, sometimes people have the question of, am I allowed to use a calculator in this class? In school, some teachers will say that they'll restrict their tests to being no calculator. So you have to know how to do this stuff without a calculator. But eventually in the future classes, like maybe in high school, sometimes they don't mind if you use a calculator and they'll let you know. So we want to be able to do these kinds of things without a calculator. So I'm not going to be using a calculator. Okay, so let's solve the first example. So in this case, I want to get m by itself, right? I want to get this m by itself. What should I do to both sides? What I'm going to do is I'm going to add 1/5 to both sides and see what happens. Okay, so hopefully you guys know how to add fractions. 2 fifths plus 1/5. Since they're both the same denominator, it's going to be 3 fifths. I'm gonna make 3 fifths. Hopefully it's not too cramped. I don't want it to look that bad. So pretty simple. We only need to do one step. M is 3 fifths in this case. And sometimes I like to flip this around. So I like to put the variable first and then equal sign and the number later because it's nicer notation. It's easier for whoever's grading my work. Ooh, sorry, accidentally zoomed in. It's easier for whoever's grading my work to read, right? Because I want to allow them to grade my work correctly. So, and I boxed my answer. Last time I forgot to box my answer a bunch of times, so I apologize for that. I'll try my best to keep on boxing my answer so it's clear what I'm doing. Okay, so m was 3 fifths in that example. And then let's go on to the next one. So solving for n minus 3.2 equals 5.6. So in this case, it's like pretty similar. I'm going to add to both sides, right? Whatever I do to one side, I have to do to the other. So in this case, I'm going to add 3.2 to both sides. I want to get m by itself. Plus 3.2 plus 3.2. I usually like to write this equal sign or this equals line underneath. And then n equals 5.6 plus 3.2. It's basically just regular adding decimals. So you add the tens place and then whatever carries over to the ones place. So this should be 8.8. Yes. Okay. N equals 8.8. And I'm box my answer. So pretty straightforward for now. And the nice thing with solving equations is that if you're ever unsure about your answer, you can always plug in your answer to the equation and see if it gives a true statement. So what I mean by that, I'm going to put an extra note. Check your answer, because sometimes this will come in handy if you don't know if you did it right or why did I put a question mark? I'll put colon, there we go. So I'll use the second example, n equals 8.8. I will substitute the 8.8 back into my original equation. So what I mean by that, n minus 8.2, this was my original equation, right? I will substitute 8.8 for n. So then what I get, sorry, it's kind of not aligned perfectly, 8.8 minus 3.2 equals 5.6. And basically just ask yourself, is this right? Does 8.8 minus 3.2 equal 5.6? Yes, it does. So that means that you did it correctly. And you can use this literally in any equation you solve, as long as it's not like that tough. Otherwise, then you might need to use a calculator. Okay. So I put a poll question like near the beginning. So 8.4 equals y minus 4.6. Okay, I'm gonna launch the poll. Give me 1 second. And then just like put your answer or your best guess. I'll give you guys a few minutes. Okay, hopefully this will work. Okay, and then you guys can have at it. Just put in your best guess. Okay, we still have one more person who needs to answer, but that's okay. I can start solving the problem. And then after, maybe after they answer, and I'll share the results. Okay, so you can, like, for the polls, you can X out the window. I don't care. So, because I'm not going to know anyways. So 8.4 equals y minus 4.6. In this case, right, whatever I do to one side, I have to do to the other side. So in this case, I would add 4.6 to both sides in order to get y by itself, right? So what I'm going to do is I'm going to add 4.6, add 4.6. I like to write out the steps that I do so I don't get confused. Okay. Bloop. Okay, so then I get y equals, it should be 13. So if you got 13, y equals 13, you would be correct. Now I'm going to end the poll because everyone answered. And then share results. Okay, so in this case, y equals 13. The other answers, I kind of just manipulated the numbers and did stuff, but you should have gotten y equals 13 if you were doing it correctly. And if you didn't, no worries. You just need to practice. Okay, cool. I boxed my answer. I'll stop sharing these results. Sometimes I forget to stop sharing the results. Okay. All right, so let's keep going here. So in this case, now we're going to go into a bit of subtraction. So in this case, I'm going to solve for r. So 0.7 equals r plus 0.4. So what I'm going to do this time, right? Remember, whatever I do to one side, I have to do to the other. So in this case, if I want to get r by itself, I want to get rid of this 0.4 next to it because it's in the way. So I'm going to subtract 0.4 from both sides. Okay, there we go. 0.7 minus 0.4 should be 0.3, right? Because the 7 minus 4 equals 3, and then you don't need to do anything about the ones place. It's both 0, so you don't need to care about that. 0.3 equals r. So r equals 0.3. And now I will box my answer. And as always, you can always check your answers, right? If you're ever unsure about what your answer is, always plug it back into the equation. And if it's true, you should get a correct statement like 0 equals 0 or 8 equals 8 or whatever, right? So that's how you like prevent making mistakes. Okay, so in this next example, solve for k, pretty similar, except we don't have any fractions or decimals this time, thank goodness. Okay, except we do have a negative. So negative 5 equals k plus 5. I want to get k by itself. So in this case, I'm going to subtract this 5. I want to get this one out of the way, right? So I'm going to subtract 5, subtract 5. Okay. So k, hopefully you guys know how to work with negative numbers. So if I have negative 5 minus 5, that means I'm going to be moving further along the negative side of the number line, right? So I'm going even further left. So that's going to give me negative 5 minus negative 5 is negative 10, I believe. Yes. Okay, so k equals negative 10. I'm going to rewrite it nicer. I always like to put the variable in front. So k equals negative 10. Yay. And that is my answer. Okay. So now we're going to go through and do some solving by multiplying and dividing. So this is another approach. And eventually we're going to combine the two approaches, addition and subtraction, and then multiplication and division. So solving for n divided by 3 equals 1.5. So in this case, we don't have anything to add or subtract. We can't we can't subtract 1.5. This is the wrong thing to do. We can't subtract 1.5, right? That's not going to get our n by itself anywhere. We're basically creating more work for ourselves when we do that. We want to find the easiest way to get to the right answer, right? So in this case, what I want to do to get n by itself is I'm actually going to multiply both sides by 3. Okay, so then m would equal 1.5 times 3 is 4.5, I think. Yes. So 4.5. And the reason why I do this, if I were to rewrite this equation, it would actually be 1/3 m equals 1.5. So this is another way of writing the exact same thing. And how do I get rid of this 1/3? Well, I want to get it to 1, right? Because I want to get the variable by itself, and its coefficient is technically 1. So I'm going to multiply the 1/3 m times 3. And remember, whatever we multiply by, that only affects the number in front. So it's only going to affect this 1/3. So this gives us m, right? And then we're going to multiply 3 on the right side, and that's going to give us m equals 4.5. So hopefully that makes sense why I do this. Because technically what's in front of this m is a 1/3, and I want to get rid of that 1/3 somehow. Another approach is you could also divide by 1/3 on both sides, but I reckon that is even more work than it's worth. Dividing by 1/3, you have to do some kind of mental gymnastics to get to your answer. I would rather just multiply by 3 because it's much easier for me to multiply by a non-fraction number than it is to divide by a fraction. Dividing by fraction is a bit too much work for me. Okay, so that's how you do the first one. M equals 4.5. I am boxing my answer. Okay, there we go. So on to the next one. In this case, we're going to solve for k. So -4 equals k divided by -5. So I'm going to rewrite this just so it's super clear what I'm doing. -4 equals -1/5 k. Technically, these two are the exact same thing, right? Because k is multiplied by -1/5. So what am I going to do to both sides? I'm going to multiply by -5. And the reason why is because I want the number in front of k to be +1. So if I only multiplied by 5, I would get -k. And that's not what I want, right? I want a positive k. So I'm being really clear. I want a positive k, not a -1. If we have a -1, it's fine. It's just one more step to get the answer. So here, k equals -4 times -5 should be +20. Don't get it confused. The negative times a negative should be a positive number. Okay, so k equals 20 in this case. And as usual, you can always check your answer by plugging 20 back in to your equation, but I'm not going to waste your time doing that. Okay. So the next one, solve for w. It's pretty straightforward. 13 equals -2w. So I want to get w by itself, right? So in this case, I'm going to actually divide. So what I like to do when I divide is I like to draw a line. Sometimes people use different notations for the same thing. I just draw a line. So divide by -2, divide by -2, because then these two 2's cancel out, And the negatives also cancel out because if I divide by a negative number, right, I still get positive 1. -2 divided by -2 is positive 1. Okay. So W in this case is going to equal -13/2. And I can just leave it like this. So some people like are kind of hesitant to leave their fractions as improper fractions. Eventually mixed numbers, the only thing that they're useful for is like baking. So usually after elementary school, you really don't deal with mixed numbers anymore. I mean, it really depends on your school and what your teacher and what you're doing. But for me, I never had to deal with mixed numbers anymore. And they were fine with me just leaving it as an improper fraction. Again, it just depends on your teacher, but I'm just saying that conventionally, I will allow you to leave it like this. I don't really care. So I will say W equals -13/2. Converting it to a mixed number just creates more room for a mistake. And it also takes up time. So I would not waste my time doing that. So if my teacher's going to allow me to leave it like that, I'm going to leave it like that. I'm not going to overthink, right? So I don't care if you leave it like this. It is perfectly fine with me. Okay, just making that clear. All right, so the next one's a bit more complicated because it involves a fraction. Solve for B, 18/5. B equals 9. So this could be a multiplication or a division one, depending on how you look at it. So like the multiplication way would be multiplying both sides by 5/18. So times 5/18. I'll do it both ways. It's all up to your own personal preference, honestly. So times 5/18, right? Because 18/5, I'm going to make this aside. 18/5 times 5/18. I can cancel out both of these, no problem. If I'm multiplying or dividing, I can cancel out the numbers. So this equals 1. We want a 1 in front of our B, so this is perfectly fine. So B equals, and then I have to do the math here, 9 times 5/18. Hopefully you know how to simplify these kinds of multiplication questions for fractions. If I have multiplication, I can divide both of these numbers by 9. So this becomes a 1 and this becomes a 2. So this equals 5/2. Yeah, so 5/2. And you can leave it like an improper fraction. I don't care. Okay, so that's the multiplication way, which I use because I think it's much easier to multiply things than to divide things, especially if it's fractions. Like if we did a fraction, I'll do it the fraction way as well, or the division way, even though I dislike it. You'll mostly see me doing multiplication. So if I decided to divide by 18/5, divide by 18/5, it's just kind of a bit more complicated to think about. Remember when you divide a fraction, 9 divided by 18/5, you always have to flip this number over. You have to flip the numerator and the denominator. I don't really enjoy doing that, right? So this turns into 9 times 5/18. It's the exact same thing, but I had to do more thinking to get there. I like it to be a bit more straightforward. So this cancels out, becomes a 2. That becomes a 1. So this is 5/2. I got the same answer, but I just like the multiplication way more. It's all down to your personal preference, though. If you like to divide, like go for it, but I don't recommend it. Anyway, so that's how you kind of deal with fractions. You'll be getting those in front of the variable a lot. So just trying to make sure that you guys knew how to do it. Okay, so there's another pole problem. And in this case, we're solving for V. It's another fraction problem, so it's like exactly the same approach as the last one that we just did. So 5/9V equals 35. And I'll launch the poll. Take your time. I'm not gonna rush you or anything. Let me launch it. Okay. And take your time, try to do the question. Okay, and while we're waiting on people to answer, I will kind of start trying to guide you on how to do the problem. Let me move this. The polls window is kind of annoying because I have to move it as I'm doing things. Okay. So how do we approach this? It's pretty much the same as the last problem, right? 5/9 v equals 35. It's pretty similar to the last one where we had the fraction attached to the variable. So in this case, I like to multiply by both sides. So I'm going to multiply both sides by 9/5. Hopefully this is clear why I'm doing this. The reason why I'm doing this is that 5/9 times 9/5 equals 1, right? Both of these can cancel. So this makes 1 on all the parts, right? Numerator and denominator equals 1. So ultimately we get 1 attached to our variable here. So v, there's a 1 in front of it now. So that's why it's okay to do this. V equals, okay, and then I'm going to do the same to my other side. So 35 times 9/5, and if it's like confusing to you, I like to write it off to the side so like it's a little bit more clear. So 35/1 times 9/5. What can we cancel out here, right? So 35 is divisible by 5, and 35 divided by 5 is going to be 7. So 7 times 9 is 63. So 63 should be the answer. One person didn't respond, but that's okay. Let's see. Let me box my answer. So you should have gotten v equals 63. I'm going to end it now. Please answer the questions. That way I know that you're following what I'm doing. But, okay. All right, so I'm sharing the results. So you should have gotten v equals 63. And how do you know that? Well, I can plug in the 63. If I'm ever unsure of my answer, I can always plug it back into the equation and do the math, see if I did it right. If both sides are equal, that means I did it correctly, right? So checking my answer. This is very useful, especially when you're doing like complicated math. 5/9 times 63 equals. And then in this case, if I'm multiplying 63 divided by 9 is 7. So we ultimately get 5 times 7, which is 35. Well, yes, 35 equals 35. So that means I did it correctly. So hopefully that makes sense. I'm going to stop sharing the results. Okay. Please do the questions. Okay. So now we're kind of getting into complicated. Oh, gosh, I forgot a variable. We'll cross that bridge when we get to it. Okay, so for multi-step equations, we're going to be combining both the addition and subtraction and multiplication and division strategies together. I like to do it one at a time, though. So if I'm adding something, I'm going to strictly be adding something to both sides or multiplying something in both sides. So I don't want to like confuse myself, like go one step at a time. So, but then sometimes we can do simplification before we even start solving the equation. So in that case, we're going to do the first example, solve for x. I always find it a bit more clear when we start doing examples. Solve for x, 6x plus 3 minus 8x equals 13. So instead of going through the trouble of trying to like add 8x to both sides, which creates more work for yourself, actually, if you do it this way, I'm going to simplify the equation first. So you notice that we have x here and an x here. We can actually simplify this by combining these two like terms, right? That's where the last lesson came in handy. 6x minus 8x is negative 2x. Negative 2x. Right, we're dipping into negatives now. So negative 2x. And then I'm going to copy down the rest of the problem because I did not do anything to these numbers. They just stayed the same. The only thing I did was mess with the variables. Okay, so now I want to get x by itself. I always like to do the addition and subtraction first before I try multiplying or dividing. Because sometimes if I try multiplying or dividing, it might make more work for myself. Ultimately, the way I like to do math is I like to eliminate the amount of work I need to do, right? Try to keep things as simple as possible. Okay. Subtracting 3 on both sides now, I get negative 2x equals 10. Okay, so that was my addition step. I'm going to write that down. Addition or subtraction, depending on how you like to see it. Okay, and then here now we have to get x by itself. So I'm going to divide both sides by -2. Hopefully it's becoming more clear now why I'm doing this. If I divide by a -2, I get 1x. So x by itself. So what's 10 divided by -2? It should be -5. So this would be my answer. And as always, I can go back and check. I can plug it back into this original equation, but I'm not going to do that. I can do it for later problems, but I don't think it's really worth it for these more simple ones. Okay, I think I messed up my next question. I didn't write the Q in there, so let me go back and check my notes, what I actually wrote. Give me one moment. Dang it, I was hoping that everything would be perfect this time. Let me see. Okay. What did I put? Oh, okay. I thought it was a 9/15. It's a Q/15. My bad. So Q/15, I should make that more clear. It's really not very clear that it's a Q. Okay, there we go. That's a Q. Okay. Better. So now it's more obvious that it's a Q. Q/15 minus 1/5 equals 3/5. So the game plan here, I'm going to add to both sides first instead of multiplying. And the reason why I do that is that I get fewer terms, right? If I multiplied first, I would still have 3 terms. But if I add 1/5, oh, change color. Red. There we go. Plus 1/5, plus 1/5. 3/5 plus 1/5 is 4/5. I was going to say something different and I caught myself. Okay. It's a Q. Q/15 equals 4/5. If I had multiplied all the terms by 15, that would have still gave me 3 terms, which I want to be as simple as possible, right? So if I multiply all sides by 15, you're actually giving me Q minus 3 equals 9 or something. So it's still like okay, but usually for like 90% of the time when I'm solving an equation, I want to do the addition steps first before the multiplication steps. But it really is situational and depends on the problem that you're doing. So be aware. My Q's look exactly like 9s. I realized when I was doing this. So I apologize. I will try to make them look more like Q's. Okay. So Q/15 equals 4/5. So I'm going to copy this down because I don't have room. So I'm multiplying both sides by 15. And why am I doing this? Well, technically what's in front of the Q still looks like a 9, Jesus. Technically what's in front of the Q is a 1/15. I want to get rid of that 15 by multiplying by 15, right? That way these two terms go away. That way I get Q by itself. Q, not a 9. Okay, Q. So after multiplying both sides by 15, Q equals, and then I can do this step off to the side too, because sometimes I get confused, you know? So 4/5 times 15. This simplifies. I have 3, right? 15 divided by 5 is 3. So 4 times 3 is 12. Hopefully you guys know how to deal with fractions. So Q, in this case, is going to equal 12, right? Whatever I do to one side, I do to the other side. So after we do that, we should have gotten 12. And you can always plug back in and check. Okay, so for this one, I might plug back in and check because it's a bit more complicated. So solving for x, 3x plus 15 minus 9 equals 2 parentheses x plus 2. So this one is a bit more complicated and kind of taps into what we did last class. So in last class, right, we dealt with combining like terms, and also we mentioned the distributive property. The distributive property is insanely important. Like out of all the properties that I learned in Algebra 1, like commutative, associative, whatever, the only one that I really found importance in was the distributive one because you use it like all the time. So do know how to use it, love it, cherish it. It will make your life 10 times easier if you know how to use distributive property. Like seriously. Okay. So we're going to try to simplify this out first before we start solving our equation, because it's a bit complicated now. If I tried to solve it how it is now, I would have to do a ton of steps, and I want to make it as simple as possible for myself, right? Sometimes I think this is a really not the best approach, but I'm kind of lazy when it comes to math, so I want to make it as simple as possible for myself, but still get the right answer. Okay, so 3x plus 15 minus 9 equals 2 times x plus 2. So the first thing I can do is I can simplify the numbers. So this 15 minus 9, I notice it's kind of annoying to have those there. It just simplifies to 6, right? 15 minus 9 equals 6. So I could simplify it to this. 3x plus 6 equals 2 times x plus 2. Okay. And then the next step here is to use distributive property. The reason why is because I have a number directly in front of these parentheses terms. So that means that gives me kind of the cue to go and be like, oh, I should use distributive property here. So I'm going to multiply 2 by both the things inside the parentheses. Hopefully you practiced last time and you kind of understand how to use distributive property. Or if you did before, totally cool. So this becomes 2x plus 4. I'm not going to go and explain too much in depth. Okay. Now I want to get x by itself. An easy way to do this is to subtract 2x on both sides. Because now you notice this goes away, but this becomes x plus 6 equals 4, right? X plus 6 equals 4. Now I can go ahead and subtract 6 on both sides. So 4 minus 6 should be negative 2. Hopefully that part wasn't confusing at all. So box my answer, x equals negative 2. I'm going to check it real quick, actually, because sometimes I'm like unsure if my answer is right. So going to check. That was really wonky. Okay, check. So 3x plus 6, I'm just writing down the same thing again. So I'm going to substitute negative 2 in. So hopefully it's clear. I inserted here and here. Those were where my x's were. So 3 times negative 2 is negative 6 plus 6 equals, and then this right term, I don't need to use distributive property. Sometimes you need to make a decision and be like, I should use distributive property here, or I shouldn't use distributive property here. And in this case, I'm not going to. I realized that the inside of the parentheses equals 0 actually. So 2 times 0 basically. Negative 2 plus 2 is 0. So this turns into 0. Negative 6 plus 6 you also notice equals 0. So I got 0 equals 0, which is true. Hopefully it makes sense. 0 does equal 0. So that means I did my math correctly. And that's how you check if you did it right. If you did it wrong, well, you need to go back and check your math. Okay, so yeah, I put here how to check your answer. Should have put it towards the beginning, but anyway. So we're going to deal with a little bit of like, it's not really word problems, but kind of, because usually they expect you to know how to translate these kinds of expressions into words. So we're going to be dealing with that a little bit. Word problems aren't my favorite thing to do, but sometimes they're necessary, and I think it's good practice anyway. So the first one, Louis deposited $500 into his bank account. He now has $4,732. Write and solve an equation to find how much was in his bank account before the deposit. Hint, what happens when you deposit money in a bank account? So if you're depositing money in a bank account, that means you're increasing the amount of money that's in there. So that means let's let x equal amount of money in bank account before deposit. So the expression I'm going to write, or equation I should say, is x plus 500 equals 4,732. And the reason why is because before he has $4,732, he has less money, right? But he deposited money, so now he has more. So his x starting amount should be less than 4,732. So this is the deposit. So money now. So that's the amount of money he has now. So hopefully it's clear why I wrote this. X plus 500 equals 4,732. And then when you solve it, it's just a basic equation. So you're going to subtract 500 on both sides. So 4,732 minus 500. This should equal $4,232, I think. Yes. Okay. So I'm going to box this answer. Sometimes they like you to write in complete sentences like he had $4,232 before the deposit. I would just leave it like this because I don't really want to waste more time. But that's basically how you kind of navigate a word problem, right? You just translate what they're saying into words and then solve the equation. So this one's pretty much the same thing. How much time do I have? I could probably do it. Okay. Jennifer is saving money to buy a bike. The bike costs $245. She has $125 saved up, and each week she adds $15 to her savings. How long will it take her to save enough money to buy the bike? Okay, so this one is pretty similar, right? The end goal or the ending amount of money is higher than the amount that she initially saved. So kind of a little sanity check. So initially she has 125. This is the amount she has saved. So it says each week she adds 15 to her savings. So what I'm going to do here is put 15x. So I'm going to say let x equal number of weeks. If I multiply $15 per week times the number of weeks, we get the total amount that's going to be added to her savings to buy the bike. Hopefully that's clear. So this is like money added in all the weeks. I'm like notating this just so it's like super clear. Okay. 245 is cost of bike. So now it's asking how long, so we need to find x, right? We need to find the number of weeks. So how I'm going to do this, I'm going to subtract. It's 245, my bad, 245. So I'm going to subtract 125 on both sides. 15x equals 245 minus 125. It's not that bad of math. It's not that much work. It's 120. So now I have 15x equals 120. And now I'm going to divide both sides by 15. Whatever I do one side, I do the other. X equals 120 over 15 should be it should be 8. Yeah, 8. I had to do the math to reaffirm my brain. Okay. So X equals 8 weeks. I'm going to label number of weeks. And if you're unsure, you can plug it back into the equation. No problem. I'm going to box it again. There we go. So hopefully that's clear, kind of how you use these concepts for word problems. Okay. And usually we like to use them to solve like money problems, but it can be applicable to other fields as well. So now we're going to work. So you see how few numbers there are in these examples. So we're going to work on isolating variables. So let me read off what I wrote. In real life, several times we are given formulas that we need to solve by isolating variables, that is getting one variable by itself by separating it from the others. So this is a bit different than what we've been doing before because it's more so dealing with numbers than dealing with letters, than numbers. So we have to be perhaps even more aware of what we're doing in this case. So, and a lot of times you will need to do this in like word problems. You'll definitely need to be isolating variables and trying to solve for them. It's very important that you know how to do this. Okay, so in the first one, we're solving a equation D equals RT. If you don't know, it's like the distance, speed, time equation. Your speed times time equals distance, but that's not important. We're asking to solve for t, that means we want to get t by itself, right? How do we get t by itself? It's pretty simple, actually. We're going to divide by r, right? If we divide by r, this r goes away. So the t becomes by itself. D over r equals t. It is pretty simple. So t equals d over r. That's all I had to do for this problem. All I had to do was divide both sides by r. So hopefully that's clear and that makes sense. Okay, so the next one says solve for a, b plus c equals 10 over a. So remember when I said I usually like to add and subtract before I multiply and divide. In this case, it's the opposite because we're dealing with variables, and you'll see why I want to multiply before I add. So what I'm going to do here is I'm going to multiply both sides. Ooh, wrong color. I'm going to multiply both sides by a. That looked like a really bad a. Okay, a. Okay. So what I'm going to do here, 10 divided by a, or 10 divided by a times a, right, cancels out the a's. If you're not sure, write it off to the side. This equals 10. And the other side, what I'm going to do is I'm going to use the distributive property thing. So I'm going to use the parentheses, and it'll become more clear why I do this in a minute. Because what I want to be doing is solving for a. A very easy way to get a by itself is just leave it here before the parentheses. That way I could divide b plus c on both sides. And yes, I can do this because this part technically is parentheses, which is multiplied by a. If it were these two terms just added together, I can't divide, right? If I don't have the parentheses, I can't divide. So in this case, a equals 10 over b plus c. So that was a bit confusing. But let's see what would happen if I had distributed the a in both numbers here and see how that would make it more complicated. So more complicated. So what would be more complicated is if I had tried to do, if I had multiplied a by both sides, and I distributed among the b and c. That would have given me ab plus ac equals 10. And the reason why this is kind of annoying is because now I have my a distributed among two terms, right? It's distributed among two terms in the b and c. So it would be more complicated for me to get a by itself, right? I don't want that. I want it to be as simple as possible. So the reason why I put the a in front and put b and c in parentheses here is just to avoid this problem. Having my a distributed among two terms rather than just one makes it more complicated for me, and I don't want that, right? So that's why I put it in parentheses, because then in this case, I would have had to take the a back out anyways, factoring the a back out, and you'll learn more about factoring later, but this becomes b plus c equals 10. And then it's like exactly the same as how we started, right? So either way, it's the better choice to just leave b and c in parentheses here. So just so you can avoid doing more work. And eventually you'll develop the intuition and be like, oh, I don't need to multiply everything out. Sometimes it's better to not have to do the work. Okay, so hopefully that's clear. If you have any questions, you can like drop it in the chat or whatever. I don't really care. I'll do my best to answer your questions anyways. So, or you can interrupt me. Okay, solve for r is this next example. C equals 2 pi r. If you don't know, that's the formula for the circumference of a circle. Sometimes these equations will have no meanings, like this one had no meaning. But the first one and this one definitely do have meanings, so that's why I'm using them. So C equals 2 pi r, that's the circumference of a circle. So now we have some context as to why we're doing this. We want to solve for r, which is our radius. So what am I going to do first? I'm going to actually divide both sides by 2 pi. And why can I do this? Well, both of these terms, or both of these are basically coefficients. Remember, pi is just a number. People kind of get confused or like scared when they see pi, it's literally just a number. It's 3.14159, whatever. So essentially we have like 6 point something times r. I can divide both sides by 2 pi. To get c over 2 pi equals r. It's as simple as that. So r equals c over 2 pi. I'm writing it a bit nicer, emboxing the nicer answers, cleaned up a little bit. But you could divide both of these parts individually. So you could first divide by 2 or divide by pi. It literally does not matter. Like I could divide by 2. Let me do this off to the side. I could divide both sides by 2. If I was like really scared of making a mistake, right? C over 2 equals pi r. Okay, well, I still need to get r by itself. Then I would need to divide by pi, not 2, pi. Gosh, okay, divide by pi. So r equals c over 2 pi. It's the same exact answer. I just did it in two division steps instead of just one. So eventually in like higher level math, you'll be able to see an equation and be like, oh, I can just divide these both at once. Like, no problem. You don't need to do all the steps to show work. I don't mind if you combine some of the steps sometimes. Don't do it for addition and subtraction and multiplication and division at the same time, because most of the time you're probably not going to get the right answer. Like don't try to like divide by 2 and multiply and add 3 at the same time in one step. It's harder to follow than if I just did both steps individually. But if you're like multiplying and dividing by 2 things at the same time, then I don't care. You can kind of do it like this. You can combine the 2 things in the denominator like this. I don't mind. It's kind of confusing, but you can like combine these. You don't need to do divide by 2, divide by pi. Like you don't need this. Not necessary. Okay. So hopefully that makes sense. What we're trying to do here is just trying to get one variable by itself and working with fewer numbers than actual letters. And this is important. Sometimes you'll be asked to define something entirely in variables. So, but that's down the line, not now. So now I have a poll, and this is going to be the last poll today, and it's the hardest. So it's okay if you get it wrong. I will go through and explain it. So v equals 1/3 pi squared h. The reason why I chose this is because it's the equation for a volume of a cone, which I thought was interesting. I like this formula. So, and we're trying to get h by itself, right? We're trying to get this one. I want to get h by itself. What kind of manipulation should I do to the other variables in order to get h by itself? And you can do it one step at a time or multiple steps at a time, but just try not to make mistakes in the middle of it. So the poll is going to look a bit weird because there's a lot of variables. So I put a bunch of parentheses around the terms so that it would be clear which numbers are being multiplied together and whatnot. So if it's not clear, you can ask me in the chat. But I'm going to go ahead and launch it. Just do your best. We're solving for h, so get h by itself. Okay, it's launched. And remember, you can like combine steps. I don't care. And if the answer choices are too confusing to you, you can just type out what you got in the chat and just private message me, and then I'll be able to see it. If you're not comfortable with like picking one because it's too confusing to you. And it's okay to get it wrong. That's why we're here. Okay, I'm gonna go ahead and start solving the problem because we're kind of running out of time and I want to let you guys go on time. So if you're still going, you can continue to enter your answers in the poll, but I'm gonna kind of go over how you should solve it. Okay, so I'll do one step at a time because I want to be as clear as possible. So I'm trying to get h by itself, so I'm gonna try to touch everything except the h. So in this case, what I'm gonna do, these steps can also be done in any order. So I'm gonna multiply by 3 first because I like dealing with numbers first. So this becomes 3v equals pi r squared h. And pi is just a number, right? I can divide both sides by pi. So 3v over pi equals r squared h. Cool. Now we only have one step left to get h by itself, and that would be to divide by r squared. So this is kind of complicated. This kind of looks a bit funky. So what does this actually mean? That means we're multiplying by 1 over r squared. Remember, when we're dividing by something, we're always multiplying it by 1 over the argument or whatever. So this actually equals 3v over, I'm going to scroll down a bit, pi r squared equals h. So this should be the answer that you should have gotten. And of course, you can skip steps to get this. You can do more steps to get this. It ultimately will lead you to the same exact answer. So the notation on my polling is a bit weird. So I'm going to explain that too. So the first option was the answer. So if you put the first one, you were right. And one person didn't respond, but I'm going to end it anyways. Please answer my polls. That way I know. Okay. So share results. Okay, so 3v over pi r squared was my first result. And my second one, I kind of just made up. So v over 3 pi r squared was my second one. And the third answer I made up was 1/3 pi r squared v. Okay, so the right one was this one, the first one. If you answer the first one, you got it right. Okay, so that was a more complicated example of getting a variable by itself. I understand it can be a bit challenging, so that's why I give you homework so you can practice it. And I'll post the solutions for the first worksheet today. And if you have any questions, you can always email me. And yeah, so I'll also post these filled notes after class as well. And I'll grade y'all's homework soon. So thanks for coming and have a good week.